This is 2018 BC FRQ number 2. The question says someone or some people on the boat try to investigate plankton cells in the sea. They somehow created a model for the density P of H, which is given by this expression for the H between 0 and 30. And when H is greater than 30, they cannot find the formulas. So they called it F of H when H is greater than 30. The only thing they know is that the F is a continuous function. The first question is, what is the P prime at a 25? You have to use the correct units and explain the meaning of the P prime at a 25. I rewrite the densities expressions in here, P of H and F of H, since I don't know F of H, so I just leave it as that. For this question, I will just use the calculators. I input the density expression into y1, and I'll take the derivative of y1, so dy1 dh, and evaluate the whole thing at h equal to 25. This gave me the answer, which is negative 1.179 millions per cubic meters per meter. The meaning of this expression is that the rate of exchange of the density at h equal to 25 meters is 1.179 millions per cubic meter per meter. Or you can say the density is decreasing at 1.179 millions per cubic meter per meter when h is 25 meters. The second question is, if you consider vertical columns of water in this sea with the horizontal cross sections of constant area 3 square meters, and how many plankton cells are in this column of the water between h equal to 0 and h equal to 30 meters. Okay, sketch something is probably always helpful. So the area is 3 square meters. It doesn't matter, it's a circle, arbitrary shape, or square, it's up to you. And this is a column going down this way. And so this is h equal to 0, this is h equal to 30. And for little areas over here, or volumes over here, and how many cells in there, you can calculate by finding the dn. So the dn should be equal to the areas times the density times the little thickness over here, which is dh. The total cells, you can use a calculator once again, is 3 times the integral. The 3 is the area of the cross section. You can put a y1 in there, and from 0, integrate this whole thing from 0 to 30, which is the same thing as we have over here. So 3 times P of H dh, you go from 0 to 30, and the calculator gives you the answer as 1675.415, and to round it to a nearest integer will be 1675. So there are about 1675 cells in the column between h equal to 0 and h equal to 30. The next question is a little bit long, and those people want to know how many cells in there when the h is greater than 30. However, they don't know what is f of h is, but they do know f of h is bounded by 0, and another function u of h. And u of h has the property of, if you integrate u of h from 30 to infinity, this whole thing equal to 105. Okay, the density will be n of k greater than 30, and it will be two parts. The first part is the integral from 0 to 30 plus 30 to k. We know p of h, and also we know the results from previous questions. It's 1675.415. The second part we don't know, and basically we want to know what is the integral of f of h from 30 to k. The only information we know about f of h is that it's bounded by 0 and u of h. If I integrate all three functions here, I would get 0 less than 30 from 30 to k, f of h, do the integral, less than, do the same thing for u, from 30 to k. And one more step is that since k is finite numbers, I can say this integral is less than this one because the k is less than infinity and u is positive. This integral equal to 105 as given. So now we go back to the original question. So this part is 105. So 3 times 105 plus this number, that gives you 1990.415, and this number is less than 2000. So that's what they ask you in the question, to say this number should be bounded by 2000. Okay, the last question is that the boat is moving on the surface of the sea, and you are given the velocities in x direction and the y direction. They want to know the total distance those people traveled from 0 to 1. This question really has nothing to do with anything we did in the first three parts. Let's be the distance traveled by the boat, and you can sketch something like that. So this is the position, and you go from 0, let's say you go all the way to here at a time equal to 1. The distance should be the integral of the speed, and the speed is given by the square root of x prime squared plus y prime squared. I substitute the x prime and y prime with the given functions and use the calculator to get the results, which is 757.456 meters. So in the end, you should answer the question. The boat traveled about 757 meters from the time equal to 0 to the time equal to 1 hour.